pulley consists of a grooved wheel that spins around a stationary axle. A rope or chain rests in the groove of the wheel. The wheel turns easily as the rope is pulled over the groove. Pulleys are used to help us move objects safely and quickly. Some work by changing the direction of force, while others reduce the amount of force it takes to move a heavy object. There are two types of pulleys, fixed and movable. A fixed pulley does not move. It helps lift objects by pulling down in order to raise a load. A movable pulley moves along the rope as the rope is pulled. A movable pulley reduces the amount of force needed to lift the load by half. The trade-off is that the rope must be pulled twice as far to move the load half the distance. The focus question for this activity is, how is a single movable pulley system similar or different than a single fixed pulley system? In Activity 8, students are introduced to the third type of simple machine, the pulley. This activity will take about an hour or 2 30-minute sessions. The vocabulary introduced in this activity is groove and pulley. The materials from the kit you'll need for the class: string and masking tape. For each group of 4, you'll need a brick, a wooden dowel, 2 plastic rings, 1.5 meters of string, the stacked washers, a pulley, and the push-pull meter. The teacher provided items include scissors and 2 dual scale rulers, and the activity sheets 8 parts A and B. This activity begins by passing out activity sheet 8 parts A and B. Students are grouped into teams of 4. Each team is given a pulley to examine and hold and are told the name of the device. Have students compare and contrast the pulley to the wheel and axle and write their responses in questions 1 and 2 of the activity sheet. Call attention to the groove in the pulley. Students learn that the groove in a pulley usually holds a rope or a chain. Students are asked where they may have seen a pulley in use. In most cases, their responses will deal with some kind of work that the pulleys are involved in. Tell the students that we want to find out how pulleys can help do work. The first thing we want to do to put our pulley system together is we're going to take the dowel rod, Johanna, okay, and we're going to lay it on the table. Now, we want this dowel rod to stay on the table so that it doesn't fall off, so we're going to use 2 pieces of tape to put across there to hold it down. We want this to be out far enough so that our pulley will fit on it without bumping the table.
Okay, how's that?
Mm-hmm. That's good. Just to add a little bit more substantial weight to it, we're going to add a brick from our kit just to help hold that down a little bit more, okay? Now, if you'll take our pulley and see the loop on there, okay, you'll put that through the hole on the dowel.
Rod goes through right there.
We're going to use a dowel, a binder clip to just hold this on, mm-hmm, so that that pulley doesn't slide off the end while we're working with it. Okay, I've actually put on 2 loops on each end so that when we're loading things on there, it just makes it a little bit easier to take things apart and add to it. So I think we'll see that later on. If you'll take that and thread it from the back to the front. Thank you. And then we're going to add our load. And from previous investigations, we've had the string on there. Mm-hmm. So we're going to add the little clip, the little loop on there, plastic ring, and we're going to put that on our string. Okay, good. And then we're going to let that drop to the floor. So if you'll drop that to the floor. Now we have our fixed single movable pulley system ready to go. Johanna, how can we get this pulley system to work?
I think we might try by just pulling down on the string to see if it lifts the load.
Well, thank you. So I see the direction you pulled down, mm-hmm, and then where did the load go?
Okay, the load went up when the string came down.
Good. And then if you'll notice, what happened to the wheel inside?
Oh, that wheel is really rotating, and I think there's an axle there between inside wheel and axle.
Okay, thank you. And this is called a fixed pulley system, a single fixed pulley system. And it's single because there's only one, and it's fixed because it's attached here. So we're going to see, let's just measure and see how far the load comes off the floor and how far the string moves. Did it feel really hard to lift that off?
It really did not feel very hard at all, but we're looking at measuring the distance.
The distance that the load has to travel and the string has to go down.
All right.
All right, so if you'll put those two rulers, one on top of the other, and let's move it over here just a little bit, and that way it'll be out of the way and we can see. And I've got my string that works out just about the same distances as the top of the ruler.
Okay.
So I'm going to pull mine down 30 centimeters, and we're going to measure and see where the load comes to when we get that there. Okay.
Wow.
So how far did the load move?
It moved 30 centimeters. The string moved 30 centimeters. I kind of see a pattern there, don't I?
Kind of had to go the same distance, didn't it? Okay, well, you know, on the last part, on some of the other lessons, we've looked at how much force it's taken to move things. So how could we measure how much force it takes to lift our load?
Okay, well, we've been using the push-pull meter. So why don't we use the push-pull meter to measure the amount of force?
Okay, before we do that, before we use it with the pulley system, maybe we need to see how much force it takes to lift the load just directly off the floor without any help of the pulley system. So let's try that.
Okay.
Okay, you have a ring on there, so I'm going to take this off and we're going to attach it just to your push-pull meter. Let's just take your ring off.
Okay, I can do that.
Thank you. We had that one on from a previous lesson, so we don't need that one.
Okay.
There you go. Just pull it on around. There we go. I'll open this one up, and if you'll slide that in.
It goes right there, just easy as that.
Okay. All right. Now, we want to lift it 12 inches off the floor. So let me get a ruler.
Distance.
30 centimeters or 12 inches. So we're going to go 30 centimeters off the floor. So if you'll pull that up, and it looks like it took about 4 units of force to lift that off the floor with that. So let's now see if our pulley system helps to reduce that force.
Okay, what do we need to take off?
We're going to take the ring off and leave it onto the pulleys, and we're going to attach it back to our pulley system.
Leave the ring on the pulleys?
No, take the ring off too because it's already attached. Okay. Okay. All right. Now we do need our push-pull meter and our ring. Okay. There you go. Just slide that in. All right. Now remember, we had to pull our load down. So if you'll take this and just pull it down 30 centimeters off the floor and measure the force. And yes, it looks like we have about 4 units of force that it took to lift it off the floor. So Johanna, how much force did it take us to just lift the load off the floor?
Exactly the same. It was 4 units of force. Now we're pulling and it's still 4 units of force. So what good is a pulley?
Right. It doesn't really seem like it makes any difference if it's taking the same units of force. So did it feel easier to use the pulley system?
It really did. Just pulling on this, pulling down on this as the load goes up really does seem to be quite easy to do.
So it looks like you can help, your body weight kind of helps to pull it down, gravity helps to pull it down, and just the mechanics of our body and how it works helps to get our load off. It just feels easier, doesn't it? Even though we're using the same amount of effort to get it off the floor. So we might want to try another pulley system to just see if that will help with force.
So this is a single fixed pulley system. We're going to try a different one.
We're going to try a different pulley system. This is a good place to stop a natural break for your class periods if you run out of time, that you can start the next pulley system on another class period. To start the next part of this activity, have students review what they recorded on Activity Sheet 8, Part A. There's a diagram on Part B that may help students in assembling the single movable pulley system. Okay, Johanna, let's put together this pulley system. We're going to start with this string,
Okay.
kind of like we did the last time, but instead of the dowel, we're going to lay this on the table, and we're going to use 2 pieces of tape to tape it down.
All right. No dowel this time.
And then we're going to use the brick, like we did from the last time, just to help secure that string to keep it from pulling off. Okay, so now we have the string. We're going to take our pulley, and we want our pulley to go through this. But before we do that, we're going to assemble the load onto the ring.
Okay. So we put the blue ring.
The blue plastic ring through the loop on the pulley.
Okay.
Okay, good. All right, so that it will hang free. And then we're going to loop our string through the hole. And if you'll hold the string, I'll do that. Now you can try our next pulley system. How does that feel?
It feels very similar to pulling it up the last time with the single fixed pulley system.
Okay, what direction are you pulling on this time?
Okay, well, this time I am pulling up.
And last time you pulled
Down.
down. And where is the load moving?
The load is moving up.
Okay, so we have a different direction on how we're pulling the system, but the load is still moving the same direction, right? Okay, how is this pulley system like our last pulley system?
Yeah, it's one pulley, and the load is the same.
Right, the load is the same?
Right.
Okay, good, all right. So how is it different than the last pulley system that we used?
Because in the last pulley system, the pulley was fixed. In this pulley system, the pulley is moving.
Ah, good, all right. Well, do you think that it takes the same amount of force to use as the last pulley system, or less force, or more force to use this pulley system?
Why don't we use our push-pull meter maybe to measure the force?
Let's do.
Okay.
Do you have that push-pull meter?
Yep.
Okay. So remember the last time we actually lifted the load off the floor. So we don't really need to do that again.
This will be the same?
It'll be the same.
Yeah.
Do you remember how many units it took last time? I think it took about 4 units of
4
force
units, right.
to lift it off the floor last time. So let's hook up our pulley system to our movable pulley. And we're going to pull the load off. And do you remember how far we pulled the load off last time off the floor?
It was 12 inches or 30 centimeters.
Okay, 30 centimeters. So let's just pull it off the floor 30 centimeters this time, and we'll just notice and see how much force it takes. So go ahead and pull 30 centimeters. And I see that our force is using about 2.5 units of force to pull it off this time, pull it up this time.
Wow, so there is a difference. It doesn't, some way it lessens the effort.
It didn't take as much force, did it? We probably need to record that on our sheet so that we don't forget that. But remember the last time, too, we also measured the distance that it took, our string moved and that our load moved.
And that was equal.
Right, that was equal. So let's try and see how far our string moves and our load moves, okay? So if you will measure how far the load moves off the floor, we're gonna have to do this a little bit differently. The measurement this time, you're gonna have to not be quite as exact. Hold the ruler in the air and then try to hold it still. I have my ruler kind of steadied with my elbow on my leg, and so my ruler's probably not gonna move too much. So I'm gonna hold that still, and I'm gonna lift this 12 inches or 30 centimeters off the floor.
Well, that's not as high a distance at all, and
So
it's
how-
actually 6.
6 inches, or how many centimeters?
15 centimeters. 6
And 15
inches.
centimeters. Wow, that's about half the distance off the floor, but I had to move my string 30 centimeters. So I had to move that string twice the distance that the load moved. We're going to record that on our sheet.
Okay.
Okay? And at this point, you want to have the students complete their activity sheet 8, part B. Looking back at our 2 different pulley systems, we called this one a single fixed pulley system. We only have one pulley, it's fixed and attached. We called this pulley system a single movable pulley because our pulley moves. Let's review what happened with our single fixed pulley system?
Okay, the single fixed pulley system, it took the same amount of distance to lift the load. It was not to our advantage.
What about the force? How much force did it take to lift it?
The force did not change. So it was not to our advantage to use it because the force and the distance remained the same.
Okay, so we had same distance to lift it off the floor with the string, same amount of force to lift it off the floor, and same amount of force to just lift it with our pulley system. Okay, with our single movable pulley system, it took half the force to lift it off the floor. But my string had to move twice the distance to only get it off the floor half the distance. So what do you think the trade-off is then for our pulley system?
Well, you're trading off distance, longer distance, less force. Okay?
Okay. For cleanup, leave a loop of string tied around the washer set. Collect all of the materials and return to the kit. Discard the pieces of string. Read the Delta Science Reader, page 8, with the article titled Pulley.